And hello again. Today I'd like to check frequency response of the DBX box because, as you have heard, it's definitely different when we are listening to the sound from the box. So I decided to measure if I can observe any difference on this box. So before doing that, so I just connected output from computer to the input of the digital card. And what I like to do, I like to use this new calibration mode when we will calibrate our frequency response of the sound card. So we will subtract it from the results. So that's what I'm doing. This will affect our charts, and we will remove those fallback in the low bass frequencies and on the highs. And let's see, it should give us absolutely flat response when we will be measuring after calibration. And then we will connect output properly to the DBX box, and we will measure response of the box itself. So it's finishing the frequency sweep, I believe, to measure differences in the sound card response. Okay, almost there. Okay, done. So let's see. So input levels, 15 kilohertz, you see on all the range, 400 hertz. Okay, so probably I have to also adjust sensitivity a little bit. Okay, 1.8 decibel difference between output. It was not set to the maximum. Okay. Input sensitivity, let me see. Okay, 2.6 decibels between output of the computer and sensitivity of the card on the 400 hertz. So let's go down. It should. It doesn't affect this chart. It will affect the chart here. So if we will do frequency sweep now on the 0 decibel, it should be basically flat on 0 decibel, because it should subtract all differences which sound card introduce. You see, it's flat. It's adjusted on the low bass, like 10 to 20 gears, where we've been struggling most of all. So it basically should be flat line. Okay, I see difference about 1 decibel in the high frequency range. So let me zoom in a bit. Yeah, here. This is wrong, so I will do recalibrate one more time now. Let's recalibrate it again and make sure that it would not produce any bumps for us. So I can make it bigger for you, so you would see it better. Okay, calibrated. Let's do measure again. It should be a very minimum deviation. It was half decibel before. Let's see if it will fix it. If not, we will just account for that. No. Okay. So I will let author of the program know that there is half decibel difference between 10 and 20 kilohertz with a bump on 15. Okay, we will just account for that. Now, what I will do, let's go to the pink mode and 0 decibel levels there below. So that's a normalized view of the music spectrum distribution. And I will connect output from the box to the input of the sound card, like that. And we'll connect output from the computer into the input of the box there. And let's see. Okay, it's normalizing. So let me show you. It's bypass mode now. In the bypass mode, you see distribution is almost linear. The drop is below 20 Hz here, like -3 decibel. Now, turning on the DBX box. And the only difference I observe is that below 30 Hz, our bass frequencies are significantly drop. Okay, like -25 decibel, you see, -20. So it's, let me make it closer view. So it's bypass. And this is the DBX box. So as you see, the spectrum distribution remains the same. Okay, now let's do white noise. So the bypass. This is the DBX mode. Okay, let's do -10 decibel. It's bypass. And it's the DBX mode. So the only difference is below 30 Hz, I believe. And do -20. Again, bypass mode. And the DBX mode. So all in all, frequency response is quite flat. The exception is frequencies below 30 Hz. And as you may see, the levels are just right there, 0 decibel. You see, we get +10 decibel light here. Okay, -20 was 0, +10, and now like on 0, we will get +20 blinking. So that's how high range we can record, +20 decibel to the original. And if we will record, we will get +10 on the output, which is not desirable, I believe, so we may reduce the level a little bit. Okay. But all in all, like we can do -6 to that, so it will be +5 here. So on metal tape it will be really fine. And if we will record +10, so we'll record like +3 decibel. So that's how significantly we can increase our dynamic range. Okay, and in this mode, let's do a frequency sweep. So let's do one without DBX in bypass mode. And let's see. So it should be flat -20. Let's restart maybe. So bypass mode, it should be flat with a half decibel bump between 10 and 20 kilohertz. Okay. Yeah, I can see it. Okay, now switching to the DBX mode, and we should have reduction in the levels below 30 Hz. Yeah, we have this reduction, you see. Okay, it added another 0.2 decibel on the high frequencies. Okay, and as you see, it has half decibel bump between 50 and 400 Hz. But half decibel would not do a significant change in the sound. So the only change you see below 30 Hz. So that's how the DBX box work. Now you may make your opinion, maybe decision if you like to buy one for you to play around. All in all, sound is really nice, so I gave to listen the sound with the DBX recording to a couple persons, and they prefer this sound over the digital modern sound. So I hope you enjoyed. So thanks again for your attention. Again, this is the DBX mode for white noise, and this is bypass mode. Nothing to complain about. Thanks for your time. Subscribe to my channel. Bye bye.